given problem, we need to find out the which system is non-linear out of a given 4 systems. So to check non-linearity, we need to decide which system is linear. So to check linearity, we need to check two properties: homogeneity and superposition. That is done by next for a given input x1, the output is y1t. For a given input x2t, the output is y2t. If we apply the superposition of these two signals, the output is equals to y3 of t. If y3 of t is equals to sum of y1t and y2t, then we can say that particular system is linear. Otherwise, it is non-linear. If we apply the above procedure to check linearity, we will get the nonlinear system out of given 4 systems. Answer is equals to option A. Question is, which one of the following statement does not pertain to the equation div dot B equals to 0? Option A, single magnetic pole cannot exist. Option B, B is solenoidal. Option C, magnetic field is perpendicular to the electric field. Option D, there are no sinks and sources for magnetic fields. Here, div dot B equals to 0 means it is a solenoidal field. That is, option B is correct.
Question is, find out the voltage V1 and V2 for the circuit shown below. So this is a very easy problem, and here the voltage value is given here is 10 volts. I forgot to mention 10 volts. Right, now we have to solve this with the help of any technique, you know. So the best suitable method here is the nodal analysis, because here he mentioned the node voltages. And also, if you solve with the help of mesh analysis, we have to apply the 3 loop equations here. That means 3 KVL equations we have to write. That means 3 equations and 3 unknowns. Then we have to find out again the voltages. Right. But anyway, here directly is given nodal voltage. But the first and foremost thing is we have to go for nodal analysis. So if you go for nodal analysis, then only we will get the 2 nodal equations. And if you go for mesh analysis, we will get 3 mesh equations. Right. So that's why we are going for nodal analysis. Right. If you see the circuit, here this is V1, and according to the nodal analysis, all outgoing currents at any node equal to 0. So if I say outgoing currents, that means our node voltage must be greater than another node voltage. That we have to assume. Then only we say that the current is outgoing from that branch. So here if you observe node 1, how many branches are there? 1, 2, 3. 3 branches are intersecting here. and if you observe node 2 also, that is 3 branches are intersecting. So our intention is all outgoing currents is positive. So and sum of the all outgoing currents is equal to 0. So here in this branch the outgoing current is V1 minus 10 by 5, and then here the outgoing current is V1 minus 0 by 2, or I can say V1 by 2, and then V1 minus V2 by 4, that is equal to 0. Right, this is the equation number 1. Now if you simplify this equation, what we will get, and we get the LCM is 20, so that's why 4V1 minus 40 plus 10V1 plus 5V1 minus V2 equal to 0. So if you further simplify this, then what we will get, 19V1 minus 5V2 equal to 40. This is the equation number 1. Again I am writing. Now if you go for second equation, that means if you have to apply the node analysis here. That means the current through this branch is V2 minus V1 by 4, because always our voltage is greater than another node voltage, then only the current will be outgoing. Right, that's why V2 minus V1 by 4 and V2 by 2, and the current 1 ampere is incoming, that's why minus 1 we have to take. So I am writing the equation here, V2 minus V1 by 4 plus V2 by 2 minus 1 equal to 0. Now if you again simplify this equation, what we will get, 2V2 minus 2V1 plus V2 minus V1 plus 2V2 minus 4 equal to 0. So if you further simplify this, then we will get minus V1 plus 3V2 equal to 4. This is equation number 2. If you solve 1 and 2, then we will get V1 equal to 2.7 volts and V2 equal to 2.23 volts. So we have to go for option